Today I will discuss about the EPC mode of contract. Nowadays, EPC mode of contract is very important for mega structures, especially for the bridges. Such contracts are also important because nowadays new technology enters into the bridge structures along with the many new types of bridges has been adopted worldwide. Secondly, we are now more focused on the aesthetic look of the bridges. Also, one more thing, earlier the constraint with the civil engineers that they can adopt only the scheduled item, but the EPC can give a flexibility in using the new technology, new material, new concept also. It is a very good concept, it is all, but there is some confusion regarding the EPC mode of contract. Friends, whenever I heard about the discussion on EPC mode of contracts, most of the people discuss about the procurement and the contract. Very few persons discuss about the engineering in this mode of contract. As we know, this stands for the engineering, P for the procurement and C for the construction. Friends, here I will not discuss on these two, meaning here I will not discuss about the scope of work, schedule and milestone, pricing and payment, risk allocations, material procurement, change of scope, subcontractor selection. These all are based on the project and there is a standard document on EPC by MORTH and NHI. Here I am interested what is engineering in EPC mode of contract and the role of authority in this engineering part. Let us know the three parts of the EPC mode of contract: the EPC contractor, owner, the authority, other party, consultant. It depends upon is the cost of the project the consultant will be recruited or not. The EPC contractor is responsible for engineering, procurement, material and constructing the project. They typically manage the team of engineers, subcontractor. The owner is the entity that commissions the fund of the project. They are responsible for providing the EPC contractor with the clear requirement and specifications. They also play a key role in approving the design plans, reviewing their progress report. The consultant is the other party, such as designer, regulatory authorities. The other party have a specific responsibility related to their expertise. As we see, all these three parties have their well-defined responsibility. In spite of that, lots of conflict has been seen in the EPC mode of contract. We will discuss what are the loopholes in the contract where contractor is playing with the contracts. The question arises, if the engineering is the part of EPC contractor, then what is the role of authority? To understand these, I divide the role of authority in two sections. One is the pre-contract responsibility and is the post-contract responsibility. Pre-contract responsibility may be before the tender and agreement, meaning if the authority has already decided and freeze the data before tender, it's okay. In most of the cases, only basic alignment are identified and they go for the tender with the tentative cost. Once the contractor finalized, then both the party, the authority and the contractor, and if already consultant has been finalized, then they can join and decide the basic design criteria. And once the basic design criteria freezed before the agreement, it cannot be changed. In both the situations mentioned above are the pre-contract responsibility. Once agreement signed with the contractor is called the post-contract responsibility. Like after post-contract, project kick-off, design phase, construction phase, testing and commissioning is the due process. But I am least interested in the post-contract responsibility. My concern is only the pre-contract responsibility in the EPC contract. To understand this in more better way, let us discuss about the engineering requirement in the EPC contract. Means, what are the data required for the bridge projects? Here I am discussing about the bridge projects, but it is applicable to all types of projects. If we are working on the mega building projects, you need all the basic and relevant data for the buildings. To understand the engineering data required, we can divide the engineering in two sections: engineering in design of bridge, engineering during the construction. The engineering design of bridge includes the parameter of design analysis like selection of site, preliminary data, hydraulic data, soil profile along the length of the bridges, navigational requirement, probable traffic volume, In the alignment, details of the bridge crossing the river. Engineering during the construction. After design finalized, the contractor may fix the methodology of construction as per engineering requirement with the consent of authority as well the consultant. Here we are concerned about the engineering in design of the bridges. As a civil engineer, when we conceive a bridge project, we go for the selection of site, collect the hydraulic data, go for the soil profile, navigational if required, probable traffic volume, and details of the data if there is any existing bridge. All data is based on the land, soil, and river, meaning land, dharti, soil, mitti, river, pani belongs to the authority only. Once the criteria related to the land, soil, and river fixed with all possible analysis, it should not be changed. This is the key point of EPC contract, and also it is the major point of conflict in the EPC contract. Contractor always try to revise these criteria on the name of design, so authority team must be well acquainted of the above data. So it's my humble request to all civil engineers, basically the young generations, to understand these criteria. Now we will discuss individually that what are the basic data for land, soil and river should be freezed either at the time of tender or before the agreement. For the land, we should freeze the probable alignment, detail of the alignment, preliminary investigation, the bridge site, the type of a structure, span, etc. Possibility of the larger tree. The most important is the traffic projection. The estimated traffic volume over the next 30 to 50 years should be assessed reasonably or may be decided by the authority, taken into consideration the socio-economic conditions in that region and likely further development and possible connectivity. This will reduce the change of scope in the contract. Change of scope is the second major point in the EPC contract. Since in the most cases COS is the part and parcel of the existing contractor, this becomes the point of conflict also. It has financial implication. It increases the cost of the project. And secondly, on the basis of change of scope, contractor claim the extension of time. The EOT on the basis of change of scope protect the contractors from the penalty if their progress is slow in the original contract. So it needs to be very careful in providing change of scope to the contractor. So my young generations need to be very careful during the fixing of the alignment of the bridge. Sometimes COS becomes important due to some public demand. So try to identify those changes initially so that it can be taken into consideration if it is required. In the current new documents of the EPC, all possible COS should be freezed within the 6 months of the contract. But there is always a space, so these things should be kept in mind. Now, the soil is one of the most important factor for the design part of the bridge. Once after fixing the alignment of the bridge, boring should be taken at the possible locations of the abutment and pier or as per recommendations of the IRC guidelines. The surface investigation should be done in two stages, that is preliminary and the detail. Preliminary to get the general ideas to know the soil strata. The detailed exploration gives the nature of soil deposit, depth and thickness of the soil strata, location of the groundwater table and engineering properties of the soil, which is most important part. Know the engineering properties of the soil. Normally SPT test is the most common test. I will not go into the detail of these tests as I know you are all well acquainted of this. The SPT value or called observed N value tells us about the consistency of the soil, relative density, phi value, compressive strength of the soil. The two corrections are applied to the observed N value in the cohesionless soil. They are correction due to dilatancy when N is greater than 15 and correction due to overburden pressure is required. Dilatancy is the soil property that describes the change in volume of the soil material when it is sheared under certain normal confining stresses. The two formula normally we use the Tarasgi formula and the Bazari formula for the correction of the N value of the soil, and for the correction of overburden pressures the peak formula is used. What I observed that in most of the cases we never go through the soil report. The nature of soil strata and soil characteristic is one of the most important factor. Most of the soil reports are submitted without the corrected value of the N. Especially in the case of river area, the correction is very important. Again, knowing the soil strata, we can plan properly. So, it is important to go through the soil report submitted by the contractor, the formula used by them. This N is also responsible for the determination of C value of the soil. In fact, this is the basis of all the engineering properties of the soil. There are two or three formula that are used for the determination of C value of the soil. Depends upon the zone and soil strata. We should freeze the formula also because every formula is applicable in particular situation. The calculation may be different in two different formula. New young team should always go through these data. This will reduce the conflict in the contract. Now the third point, river, or water or pani, which means the hydraulic data. Identify the nearest benchmark with the reduced level, which is again one of the most important points. Few data like HFL, LWL, OFL, navigational requirement are very important data. It should be cross-checked by the irrigation department, the CWCs, 100 years data. The old people observation is also important, as will the existing breeze data. If there is any existing breeze on that river, those data may be taken for the analysis purpose only. These data are very important in the bridge design and an important factor in deciding the depth of the foundation, and also an important data for generating the conflict with the contractor. So please be very careful in deciding these data. Once after all possible analysis, freeze the data and don't give any space to the contractor to generate the conflict. One more important data is meandering nature of the river is also a major point of conflict. So please go through these data very carefully. Once we adopted the data related to land, soil and river, dharti, pani or mitti, we reduces our 50% of the conflict in the EPC contract. As well, we can have the confidence that the basic data has been adopted after very careful and possible analysis. Now, as per design norms, the design engineer of the contractor will fix the other data, other parameter as per the requirement like dead load, live load, impact or dynamic effect due to vehicles, impact due to floating bodies, wind load, longitudinal forces and centrifugal forces, etc. Our role is to keep eyes only on these factors taken into design. So friends, EPC is a very good mode of contract. Only few precautions required. Very new model, new types of structures as well. Worldwide new standards of the bridge construction is possible through this mode of contract. If you feel this content is useful to you, please like, share and subscribe.